Terrified?
Terrifying.
How many times have you looked at yourself in the mirror since you've been on this earth?
A lot, but that was so close. I've never looked at myself that closely.
Oh, yeah.
Really?
Oh, the pores on your skin just
Yeah.
appear like craters on the moon.
Self-conscious.
Yeah.
Awesome. I always think I'm most terrifying.
It's like the mirror from the Snow Queen story. It reveals everything bad about yourself.
I can see that. Okay. So, my object distance is 40 centimeters. Tate, is that a positive or negative number?
Object distance.
Yep.
We broke,
Positive.
Positive.
I thought
Okay.
we broke tape for a second.
Right? So, we're going to figure out the image distance. So we're going to take 1 over f minus 1 over so is going to equal 1 over psi. So we're going to take 1 over my focal length, which is going to be 1 over 20, minus 1 over 40, it's going to be 1 over psi. So my psi here, if you do the math, is going to be positive 40, right? Okay. Now, here's the significance of that positive 40. So the light is hitting, okay? It's bouncing off, and it's coming in here like this. So this image is in the same direction that the light is traveling, okay? So light's hitting, it's bouncing off. This is the direction of the light. This is where my image is. So it's in this, what?
I think I understand.
An epiphanal moment?
A little
A
bit.
little bit. Okay. I can handle little epiphanal moments at this point.
That
I
makes
can
one
take
of
that
us.
and run.
Yeah, I need that. I need
Okay.
that moment right now.
So, here's the deal. Now, let's think this through. So, in this situation, I need my magnification, right? So my magnification, let's tackle that. So my magnification is my negative psi, right, which is going to be negative 40, divided by my so, which is 40. So I get a negative 1. So, why is my magnification negative?
Because it's upside down.
Because my image is upside down. So, it has a value of 1. So, my object and my image are going to be the exact same size. Now, when you go to draw this, okay, especially on mirrors, okay, this is what we talked about yesterday. There's always two that I always draw, which are always easy. So, this is my object. So what I always do is I take that object, okay, here's this primary axis, and however tall that is, I flip it down over here, okay? I make it that exact same point. Because then what's going to happen is that I'm going to draw a line through here that's going to hit the center. So you bring a line here that's going to hit this, it's going to go to that center, and then it's going to get reflected symmetrically back to here. So that's always going to be one of your points. Now, in this situation, it just happened that that's where my image is going to be. It's not always going to work out that way. In this case, it just happened to. So don't look at this and go, oh, my image is always going to be directly underneath my object. It happened to work out that way, okay? But don't think that that's always going to happen. But here's what is important, is that once I get this symmetrical line established, I know that that image has to be somewhere in this triangle, okay? So that narrows it down. I know it has to be somewhere within that triangle. So then the second one, you draw it in parallel with it. It's going to hit this, and then it's going to go through that focal point, and then it's going to come back over here. So now that gets me my second point. So put one through the middle, put one parallel with it, and then through the focal point. Now your third one goes
Through the focal point.
through the focal point, hits this, and
Goes
then runs
parallel.
parallel with it. Okay? Feeling better about it. Okay.
Slate.
Sort of.
I'm
Sort
borrowing
of.
a ruler.
Vaguely.
Okay. So, is the image upright?
Nay.
No. Okay? It's not because I've got a negative magnification.
And it's a mirror.
And it's, well, hold on. Okay. Good with this one. All right. Now, here's the last one that we have to get through. Still with the concave mirror, but now what's happening here is that my object distance is 20 and my focal length is 40. So what's happening here is that your focal point has moved way out here and your object is inside of the focal point. So this is when you've got it like real close. So this is what it made it so terrifying for Liza when she brought that thing in close, okay? So she brought it in close. You are inside the focal point. So one of these you're outside the focal point, one of these you're inside the focal point. So is my focal length still positive?
Yes.
Not always, but in the,
Yeah.
within the confine of being a concave mirror, it's always going to be positive. So I've got a positive focal length of 40 centimeters. Okay. My object distance is 20. Still positive? Yep. Okay. So now I need to get my image distance. So if you do this, if you take 1 over 20 minus 1 over 40, you get a negative 40 centimeters. So here's the significance of this negative value. So the light is coming in here like this, but what I'm seeing is an image that's on the opposite side of the mirror. So this has to be a virtual image because of the fact that you're making this so it's going to appear over here. Okay? Now, this is where you have to get into, to a certain extent, the physiology of this in terms of how this is interacting with your eye. So what these dashed lines are representing is that your eyeball is out here, okay? Your eyeball is here. So your eyeball is catching this ray that's reflected off this mirror. But so your eyeball is catching this ray, so your eyeball thinks it's going out like this, okay? So the same thing is happening with this one. So this one comes in, hits this, right? Your eyeball is here. So your eyeball is trying to trace these rays back to this point. So this is why when Liza held that thing out there, okay, then what happened when you held it a long way away? What happened to your image? Was it upright or was it inverted? It was upright. Because now she's making this image out here, right? But she looked, we got an upright image that's appearing, but she's like on the other side of the mirror.
I thought that was the other one.
Yeah.
Yeah.
Huh?
I thought that was the one outside
Yeah,
the focal
you said
point.
upright.
Oh, I'm sorry.
You keep saying upright.
Okay. My bad. So, with this, yeah, you're going to create an image that's upright, okay? But it's going to look like it's on the other side of the mirror. Now are we
So
good?
is this
Yeah.
the close or far away?
This is the one where you're inside of it. So here's your object distance and you're outside of it. So this is when you bring it up close. Okay.
What?
Yeah.
You
Oh.
said far away.
Okay, my bad.
Hey, we understand. Me and Dave
Okay, we're good
understand.
now.
Okay.
We understand.
Okay, so with this one,
You are
right?
Latin.
I just want these.
So sorry, viewers at home.
I get it.
So hold on.
Breaking
I
news.
screwed you up. I apologize. Okay? Okay. My apologies. So, this is why this is terrifying, because your pores look huge,
Yes,
Ah.
I'm already huge too.
okay? This is why this looks terrifying. So with this one, you're inverted, okay, but you look smaller. So this is when you're holding it out, and this is when you're up close. My apologies for that. Okay? Okay?
So
Can we
will
make
there
it
ever
more
be a
confusing?
mirror that makes the image
Just
look,
the way.
or look like it's coming from in front of the mirror, not behind it? Or will a mirror always create a virtual image?
Well, no, what you'll see is that you can create a real image. That's what I showed you yesterday, when you project it onto a screen. So you can make a real image that's projected onto a screen.
With a mirror?
Yeah,
Hopefully.
I wasn't there for that.
okay, well, you can.
Well, I caught it all
That'll be
on
the point of the
camera.
lab yesterday.
Yeah, I just forgot to watch it.
Yeah, okay,
So I had to meet.
all right, so,
Understandable.
let me make sure I got the numbers right here. Okay, so my magnification then is gonna be
2,
a negative of a negative 40
which means 2.
divided by 20, which gives me a magnification that's positive 2. So my magnification is positive, so therefore it is
Upright,
upright.
and it's a virtual.
It's a virtual image, okay? Now, this one over here, and this is what I showed you yesterday, this one is actually a real image that you can project on the screen.
Wow.
That's what I did yesterday,
Fair enough.
okay? When I had the half screen and it bounces off and you can make this show up on a screen.
But that's only when it's at the focal distance or.
Oh, no, it's just as long, well, it doesn't even have to be that. It just has to be outside of that focal point.
Okay, yeah, that's what.
Yeah. It just has to be right there when that happens. Okay. We're good with it. All right, so your assignment. Oh, I need a new page.
Questions from one?
So
you need
if-
notebook and papers.
Notebook, paper, and graphic.
I didn't know you needed notebook, so I thought you had notebook paper.
I do have notebook paper, it's just, it has Christmas sticky again last year. And it's a lot less
Wait, repeat me.
It's an electrocuted electric.
These are all problems, there's no questions.
Oh,
I don't know if that's a good thing or a bad thing.
that means there's probably not many of them.
You better prove me wrong, Ryan.
Yeah, no.
Yes, sir. Settle it.
We do not speak of those problems.
Oh, there's only 5?
No, there's more.
Oh.
That you have to like draw out. Okay?
Oh, only 5 we have to drop them.
Yes.
Okay.
So these, and again, when you're doing these, okay, I know you can all use the Thin-Lens equation. In the spirit of how I want these done, is that I actually want you to try and draw them out first, okay? Get your measurements, choose your scale, label your focal points, label your object, label your image, okay? Clearly, I beg of you, clearly, Peyton, listen to me. Clearly label them, okay?
Clearly.
And I don't care if you use an arrow, a candle, do something that I can clearly distinguish what is going on and what's your image and what's your object. Is it getting flipped over or is it not getting flipped over? On these diagrams, I want a minimum of 2. I prefer 3. So, if you look at what you want on there, there's 3 things that you're expected to tell me. Is it an inverted or upright image? Is it real or virtual? And then your image distance. Okay, so those are the 3 things that I need and the diagram on these problems. Now, the other ones, 30, 34, 36, 38, and 39, these you can just use the Thin-Lens equation. If you want to make a sketch on them, you can, okay? But on these, you can just use the equation, but pay attention to what they want on all of these. They want the image distance and they want the image height, okay?
Oh, well, I assume we have the initial height, which just means they're disproportional.
Or, well, no, because they're going to give you the object height. You're trying to find the image
Yeah,
height.
proportional to the, never mind.
So we're getting
For the image
the
height, do you just multiply that?
whole
by
and we need to find the height.
Yeah, once you get your magnification.
Yeah, no.
So,
H.
now, they don't actually ask you for this, but you might keep in mind, like, are these real images, are they upright, okay? You don't technically have to give that information, but that might be something that, if I were you, I would think through. Okay. There you go, kids.
Yay. Wow, just
I beg of you, leave space for these.
I specifically got a piece of graph paper for these.
Okay.
hit them on
Fun.
one.
No.
You want a second one just in case, Ryan?
Because the book uses
If I need more space than this,
This is an image
use the
that
back.
hurts me
fair enough.
you see when you wrote.
so much.
Ryan's
It
like,
hurts so much.
Let me see.
It's
I don't
so
think I'm gonna
much.
need more space than this.
So much pain.
Look at the space these have.